Okay, I'm going to use Descartes' rule of signs to determine the number of positives and negatives and imaginary roots. Okay, what this tells you is how many you could possibly have. It does not tell you what the answers are, but it tells you how many possibly you could have. So to figure out how many possible roots I should be expecting, I always want to look at the highest exponent. So in this case, my highest exponent is 3. So my total number I could possibly have are 3. So to find out the positives, I want to just look at the equation the way it is, and I want to figure out how many times the sign changed from positive to negative, or negative to positive. So no change here. Okay, but then when I go to the next, I went negative to a positive to a negative, so that's a change. And then when I went back to the next one, I went negative back to a positive, so that's another change. So in this case, I have 2 changes. And what we learned was the little loophole was if you can go down by 2, you should go down by 2. So for positives, I'm going to say 2 or 0, because I can go down by 2. Okay, to find the negatives. All right, to find the negatives, I'm going to take the original equation, and I'm going to put a negative x in wherever there's an x. And then I'm going to adjust the sign. So I'm going to write that in right now, and then we'll talk about what the easy trick is. So if I have negative x cubed plus 5 negative x squared minus 4 negative x, and then just plus 3, the constant doesn't change. Okay, so what we talked about, the easy thing to do is the only ones that change are the ones that have an odd exponent. So the first term has an odd exponent, so it's going to be a negative 3x cubed. Then it's a positive exponent. That guy didn't change, so it stays positive. Okay, the third one, that's an odd, so that would change, so that's going to now be positive 4x. And then the constant doesn't have any exponent, so it stays just whatever it was. All right, so now I have that, so I'm going to look for the changes on that. So I start with the negative, and I went negative to positive, so there's 1. Okay, I didn't change. From here to here, it didn't change. I went positive to positive, then positive to positive, so I didn't change again. So I end up with 1 change. And I can't go down by 2 because that would get me to -1, and there's no such thing as a negative number of solutions. Okay, so the chart is, I'm going to use these ideas that I just got. So I'm going to use all these values and make a chart. So I know my total number that I'm looking for is 3. Okay, so when I add up the columns, I'm going to have 3. So for the chart, the first thing I'm going to do is I'm going to look at the positives, so I'm going to start with 2. So if I have 2 positives, and I would have 1 negative, because that's just my options, so that I'm supposed to have a total of 3, so 2 and 1 is 3, so I'm going to have 0, there's no more left for imaginary. So if that case, I would have no imaginary. All right, so if I did this synthetic division for this problem and I got 2 positives and 1 negative, I know I'd have no imaginary numbers. Okay, my other option is I can have 0 positives, okay, and I still can only have 1 negative. Okay, so now I look and I have 0 plus 1 is just 1, but I'm supposed to have a total of 3, so that means I need 2 more here. So those are in this case, so if I had no positives and 1 negative, my other 2 answers have to be imaginary numbers, which means that they have to have I in it. Okay, so that is one of the problems. Okay, second problem, I'm going to go a little quicker with this one. So my total number of roots is my leading exponent, which in this case is the 7. So I got that from the highest exponent. So that is a 7. So there's 7 total numbers of roots that I could possibly have. All right, if I want to find the positives, I'm going to look for the change in sign. Okay, so let me see. I did not change from here to here, but I changed from here to here. So that's 1, and then I went back to positive, so that's 2. Stayed positive, stayed positive, stayed positive. So there are 2 changes I had. So again, I'm going to go 2 or 0 because I can go down by 2. Okay, so to get the negatives, I'm going to use the idea of if it's an odd exponent, the sign is going to change, because I'm going to do the negative x, and I'm not going to write it all out, but I'm going to change it right away. So if the exponent is negative, I'm going to change the sign of what it is right now. So the first term, actually, I'll show you. Let's highlight it. So this term is odd, this term is my odd one, this one is my odd one, and there's no x, so I don't have another odd one. So those are my 3 odd terms, and I don't need a placeholder when I do this. So those are my odd ones. So I'm going to change those guys. So the first one I'm going to change to negative, let me get back to here. Okay, so I'm going to change that to negative 5x to the 7th, and then I'm going to keep that to plus 3x to the 6th. Change that now to positive 2x to the 5th. Keep that positive 3x to the 4th. Make that this other sign, so 9x cubed, then plus x squared plus 1. Okay, so now when I do this, I'm going to look for my sign change again. So I went negative to positive, so that's one change. Positive to positive, positive to positive, and then I'm going to go positive to negative, so that's 2 changes. Negative back to positive, that's another change, and then I stayed positive. So in this case, for negatives, I'm going to have 1, 2, 3. So again, I would go 3 or 1. So I can reduce by 2, so I should do that. Okay, my chart. Okay, so my chart, I'm going to use so I have 2, I want to have a total of 7 this time. Okay, so I'm going to start with 2, and then I'm going to use 3. Kind of doesn't matter where I start, but I know I need to have 2 positives, and I know I need to have 3 negatives is one of my options. Okay, so that makes 5, so that means there's 2 left, so I would have 2 imaginary. I'm going to stick with 2 this time, but now I'm going to go 2 positives, and then I would have 1 negative, because I'm trying to use the 3 and the 1 in this case. So I can go 2, 2, and then 3 and the 1, and that will take care of those 2 options. So that gives me 3, and then I have 4 left. Okay, now I'm going to switch to the other number of positives, so I can have 0 positives and 3 negatives, which that gives me 3. I need 7, so that's going to be 4. And then the last one I'm going to do is I'm going to go 0 again. But okay, so my last check for the negatives would be to check 1 negative. So 0 positive, 1 negative, that would leave me with 6 imaginary numbers. Okay, so my final answer for the imaginary numbers are going to be, I could be 2 or 4 or 6. So that is all the possible answers I could get out of 7. 2 of them could be positive, or 0 could be positive. 3 could be negative, or 1 could be negative. 2 or 4 or 6 could be imaginary. So basically when I solve this problem, I would find out there's going to be some imaginary numbers in it. Thank you.